Good morning, everyone. Today we will continue our lecture on chapter 4, but part 2, which is 2 and 3 force member. Right. So what is 2 and 3 force member? So when force are applied only 2 points on a member, the member is called 2 force member, like a figure A. So this is figure A. They said that when a member have 2 points, the force apply only at 2 point, this point and this point, so they call it as a 2 force member. Okay, so 2 force member must satisfy equal in magnitude and opposite direction, and also equal in line of action. That's mean they must have same magnitude but opposite direction. Okay, and in one line. Okay, in one line. Alright, so that's it. That is 2 force member. Alright, if your member is like this, alright, let's say like this, and they have 2 points, let's say this is point B and point A is here. Alright, so the line of action is here, so the force must take either this way, alright, this way, or this way. Must be opposite direction. Alright, okay. So if you have another shape like this, let's say you have like this, alright, and then you have point A is here and your B is here. Alright, so the force in A and B must be in this direction. Alright, same value. Let's say this is F 5 Newton. This is also F 5 Newton, and in one line. Okay, so that is 2 force member. Alright, that is 2 force member. Okay, if you have straight geometry, is easy. Okay, so your force must be either in this direction or in this direction. Alright, equal magnitude but opposite direction. F in one line. Alright, that is 2 force member. So if you have different, okay, if you have different direction, is wrong. It's not 2 force member. Alright, it's not equilibrium. Right, so this 2 is in equilibrium. Alright, okay. So next is 3 force member. So what is 3 force member? The member has 3 force. You have force 1, force 2, and force 3, and all these force must meet at one point. Let's say point O must meet at one point. Alright, so this is become equilibrium. Syarat dia or condition for force in 3 force member, or they must have parallel. Dia two condition, either they can meet at one point or it can be a parallel. Alright, so in this subject we will more concentrate on 2 force member, okay, instead of 3 force member. 2 force member is, we will concentrate on this one much. Alright, we look into problem 8. Okay, so the overhanging beam is supported by pin at A and 2 stroke BC. Okay, determine the force horizontal and vertical component of reaction at A, reaction at B on the beam. So this is A, this is B. Okay. Alright. If we do not use two force member, okay, if we do not use two force member, remember, so we will come up with this. Alright. So A, then there's B. Right. So this is pin AX, AY, BX. This is also pin BY. Okay, you have 600 and you have 800 and you have moment. So how many unknown we have here? Okay, so we have 4 unknowns: AX, AY, BX, BY and BX. We have 4 unknowns. Instead, we can only solve for 3 equations, which is summation of fx0, summation of fy0, and moment at A is 0. We only have 3 equations, but we have 4 unknowns, so we cannot solve this. Okay, so how we want to solve this? We must identify any two force member. So in this case, we have this one is two force member. So in two force member, you can simplify the force. Okay, for the force at, let's say, at point B and point C is in this line. Okay, we assume the force is in this way, F, B, C, and this way, F, B, C. So that's the force in this strut. We call it strut. Okay, so instead of we use two force in point B, BX and BY, we only have one force, which is FBC. Let's say this is also FBCY, FBCX. So we left only with one force because we know already the direction. The resultant force we know already. This one is component force. Alright. So clear why we need to use two force member. Okay. Now we can draw the FBD. Okay, we can draw the FBD. Only draw for one member. Alright. So this one we have AX, we have AY. Alright. And then we have B. Point B, we have only one force, this one. Okay, let's say, so this one is F, B, C, and then we have 600, and then we have 800, and also moment 900. That's it, our free body diagram. So we have 3 forces, AY, AS, and FBC. So we can solve it using equation of equilibrium. Alright, for equation of equilibrium, summation of Fx is equals to 0, summation of Fy is equal to 0, and moment at A is equal to 0. So I suggest you start with moment first, okay, because basically they have only one unknowns. We start with moment at A. So moment at A is equals to 0. Alright. So this is 1 meter. This is 1 meter. This is 2 meter. Right. So the angle theta is tan inverse 1.5 over 2. Right. So this is 36.87 degree. So 36.87 degree. Right. So moment at A, you have 600 times 1 clockwise, negative, plus FBC sine 36.87 times 2. Alright. For the cos, you don't have because it one in one line. So moment. So minus 800 times 4. Alright, and then minus 900. For this one, you just add because this is already moment. No need to times distance. It's clockwise, it's negative, right? Equals to 0. Okay, look, you only have one unknowns, so you can solve directly, right? So FBC is equals to, take out your calculator and you calculate the answer. You have 600 minus 800 times 4 minus 800 times 4 minus 900, okay, divided by 2, okay, divided by sine 36.87. So you get the answer 3916.6 Newton. Okay, so symbol is positive, so your direction is correct in this direction. Alright. And then summation of fx is equals to 0. So you have ax plus fbc cos 36.87 equals to 0. Alright, FBC already known from this value, so you got the answer AX is equals to 3916.6 times cos 36.87. So you get the answer minus 3133 Newton. So why minus? Because your assumption of direction, this one is not true. So the correct direction is the other way. Or your answer should, you can write like this, 3133 Newton this way. Okay, right. It's not wrong, but your guess is not true, so you can simply write like this. Okay, it's not wrong your answer. So summation of fy is equals to 0. So you have ay minus 600 plus fbc sine 36.87 minus 800 equals to 0. So you get the answer ay is equals to, we have 600 minus 3916 sine 6.87 minus or plus 800. Okay, so you get the answer I think minus 950 Newton, right? So you also got negative, so your direction should be this way. Alright, that's it. Okay. Alright guys, now we look into problem number 9. Alright, so we have a arm holding the load as shown in figure, right? Forearm hand have mass of 2 kilogram. Alright, so this hand they have mass of 2 kilogram, and no, the load is 2 kilogram and this hand is 1.2 kilogram. So this one is 2 kilogram and this arm is 1.2 kilogram. Alright, and their center of mass is located at G1 and G2. So this one is G1 and G2. Determine the force developed in the bicep CD and the horizontal and vertical component reaction at the elbow joint B. Alright, so they're asking for the force developed in CD. Okay, so the forearm supporting system can be modeled as the structure shown in lower figure. So they have simplified our problem into this figure. Right, so they want to know what's the tension force in CD and reaction at B. So this is what? Pin or what? So this is a pin. So pin you have two. One is BX and the other one is BY. Alright. Look at this figure. You have two components. This bar A, B and CD. So when we look at this, so ask yourself. So this one is two force member. Okay. This one is two force member, which is force at point D and force at point C. Alright. So when two force member, you can simplify using only one force at C. If not, you have two force at C and two force at B. So you have four unknowns. So when we use the two force member, we can simplify our solution. Right. So step 1, draw the FBD. As usual, you can draw the FBD. Right. You can draw the FBD. Okay. Draw the FBD showing all the forces. Okay. So at A, we have force due to gravity. Weight. G, and then at G2 we also have weight, and then at B is spin, so we have two forces, BX and BY. Remember, pin you have two forces, for roller you have one forces. Okay, if you have roller symbol is like this, you only have one forces. Alright, for pin you have two forces, in X and in Y. Right. What else? For the member CD, you have force for the member CD. Since this is the two force member, you have this kind of force. Only one direction and one force, FCD. If not, okay, I'm telling you, if not, you will have two forces. If we don't consider two force member, you have FCDX, FCDY and FCDX. So you have four unknowns, FCDY, FCDX, BX and BY. So you cannot solve. You need only have maximum 3 unknowns. So when we use two force member, we can use directly this type of forces. Alright. Okay. Right. So we can label the distance is V1 0.1 meter, 1.35 meter, and then here is 0.065 meter. Alright. So angle here is 75 degree. Right. So G1, the question of G1, the weight are 2 kilogram. So 2 times 9.81 in Newton, and then for the G2 you have 1.2 times 9.81. So you got the answer here. How much? Yeah, take out your calculator. Alright, so you have 2 times 9.81, 19.62 Newton, and this one is 0.2 times 9.81, 11.77 Newton. Alright, now we use these three equations. Summation of Fs is equal to 0, summation of Fy is equal to 0, and summation of moment equals to 0. So we start with moment first because it will basically make you life easier. Alright, so let's take a moment at B. Alright, you can take anywhere, but the easiest way you take at the location where the force are exist. Let this one Bx and By. So you have 19.62 times the distance from here to here is how much? You have 0.1 plus 0.135 plus 0.065, 0.3 meter. Okay, so times 0.3. This is minus, since this force will make it turn clockwise. Alright, clockwise. Right, and then you have minus 11.77 times distance from here to here is 0.135 plus 0.065, 0.2. Okay, 0.2. So you have 0.2 also minus, and then for this force FCDY you have oh sorry, this one we turn this one counterclockwise kan, right? So this one is counterclockwise, so counterclockwise is positive. So this one we turn FCD, we turn minus lah. FCD sine 75 times 0.065 equals to 0. Alright, that's all. So we can directly find the FCD. So FCD is equals to, what is the value of FCD? Right, take out your calculator, you find it 19.62 times 0.3 plus 11.72 times 0.2, okay, equal to 8.23 divided by 8.23 divided by sine 75 divided by 0.065. So you got the answer 131 Newton. Alright, so symbol is positive, so your assumption here is correct, this direction. Alright, so we go to the second equation. Summation of fx is equal to 0. So this one is y direction only, this one is y direction only. So you have this type of force, FCD cos 75 degree plus BX is equals to 0. Alright, so FCD is 131, so you got the answer BX is equals to 131 times cos 75, you got answer 33.9. Alright, this one is minus 33.9 Newton. Minus means your assumption here is wrong, so the correct answer you should write it as 33.9 Newton this way. Alright, so for the summation of Fy is equals to 0, right? So you have minus 19.62 minus 11.77 plus FCD sine 75 plus By is equals to 0, right? So you got answer By is equals to By is equals to 95.3 or 95.4. Okay, you got answer 95.4 Newton. Alright, also negative, right? Also negative. So your direction should be downwards, right? So the correct dimension, you can tell it as a, right? You can draw it as a By is here and Bx is here, the correct one, right? Okay, that's all for problem number 9.